Today we are going to discuss about the solution of algebraic and transcendental equations. Okay. Now, what do you mean by this? So we will be basically talking about the nonlinear equations, basically nonlinear equation. Okay, this is also applicable for linear equation, nonlinear equation. And we have two types basically, which is algebraic equations and transcendental equation. Okay, so for example, this algebraic equation, consider an equation that f of x, let's say f of x, for example, x square plus 3x plus 4 is equal to 0. This is a algebraic equation. Now in the case of transcendental equation, for example, e power x minus 2x is equal to 0. This is a transcendental equation. So you can see that this is an algebraic equation, and this is the power, actually the power of x is equal to 2, and this is a nonlinear equation, it's a nonlinear equation. Okay, and this is also, you can see there is e power x, so it is a nonlinear equation. So these are all the different types of equation. That means I can write this equation as f of x equal to 0. Then what do you mean by the solution? Then the solution means that, what is the solution? Solution means that for some values of x which is equal to xs, this equation f of xs will be equal to 0. It will be satisfied. Okay, it will be satisfied. So in general, I can write an algebraic equation like this, and finding the solution means that I will put f of x is equal to 0, and we will find what is that value of x which make f of x is equal to 0. Similarly, I can write this also as some, let's say this is f1 of x, I can write this as some f2 of x which is equal to 0, and for some x is equal to xs, for some x is equal to xs, I will get f2 of xs will be satisfying the equation f of xs is equal to 0. That means it is nothing but, if you have an equation, let's say another example, which is a algebraic equation, you can see here, I will consider x square minus 2 is equal to x square minus 2. Now we'll put f of x which is equal to x square minus 2, which is equal to 0. That means for some values of x, this will be 0. That means x square is equal to 2 and x is equal to plus or minus square root of 2. That means that if you plot this equation, you will be getting here something like this, and this will be plus square root of 2, and this will be minus square root of 2. You see here, this is your f of x, and your f of x at this point, your f of x is equal to 0 at this point. You can see here. So this is f of x and this is x. So y-axis, y is equal to f of x. Okay. So you can see here that this is 0, and here also it is 0. So you are going to find where it is crossing. So this is the root of this equation. So we can say that these are all nothing but the roots. These are all the roots of this equation f of x, okay, which is equal to x square minus 2. So this method, actually, I am using directly. I am solving this equation directly. I am solving this equation, and this method is known as the direct method. Okay, direct method. So we can have two types of method, direct methods and the indirect method. So this is the direct method. You know that how to find the solution of an equation. For example, x square plus ax plus b is your f of x. Then you can to find the solution of this, to find the solution, what is the value of x? Then you have to put f of x is equal to 0. That means that x square plus ax plus b is equal to 0, such that a is not equal to 0 and b is not equal to 0. Okay, in this case actually I can find the value of x is equal to minus b plus or minus square root of b square minus 4 into a into c whole divided by 2a. You see here that I can solve this equation directly by using some technique. Okay, this is my direct solution. But this kind of solution is not always possible. Suppose if you have a very complicated equation, then it's not possible. So this kind of method anyway, it is known as the direct method. Okay, so to find the solution, to find the solution, of nonlinear equation, you have two types of method. First method is the direct method. Okay, direct method, that's what we have discussed now, directly solving the equation. And another one is known as the indirect method, which is also known as the iterative method. Like your Jacobi iteration, this kind of iterative method is possible here also, but it is not like Jacobi iteration, it is in a different way. So it's like iterative method. So there are two types of method which is possible for solving and the nonlinear equation. And we can actually again classify our indirect method into many types. We have many types of indirect method. First one is the bisection method. Bisection means two section. Bi means two. Okay, so bisection method. The second one is the method of false position. So these are all the methods that we are going to discuss. And third is the Newton-Raphson method. Okay, and the fourth one is the successive approximation. Okay, and I would like to tell you these first two methods, actually we will call these two methods, basically these two methods we will call it as the, both are coming under a special category, bracketing method. Okay, bracketing method. And the other one, these two we will call as, which is coming under the category of open method. Okay, then we will see what is this bracketing method and what is open method. And I think there is one more method we will be discussing, which is known as the secant method. Okay, secant method. So this is how, so basically we will be classifying how to find the solution by using two methods. These are all the two methods. Basic method, that is the direct method, that we have already seen what is direct method. This is the direct method. Okay, and then we have something known as the indirect method, and this indirect method we can classify into many types. Okay, these are all the indirect method, that is bisection method, method of false position, Newton-Raphson method, successive approximation method, and secant method. And out of this, the first two actually which is coming under the category of bracketing method, and then open method. So we will see what is this bracketing method. So we will first start with the bisection method. Okay, we will start with the bisection method. So we will start with the bisection method for finding the solution to nonlinear equation. So we will see how to find the solution to nonlinear equation by using bisection method. First of all, I will be explaining about the logic behind it. So we will discuss about bisection method. Okay, bisection method. Now you know that we have an equation f of x, and this bisection method is a bracketing method. I have told you it is a bracketing method. Why it is a bracketing method? Two initial points are given, actually two initial points are given, or we find two initial points. Let's say it's is A and B. That means we assume that we assume that the solution lies between A and B, but there are some condition for it, because there are some conditions should satisfy. We cannot simply assume. Okay, simply assume, it is not a simple assumption. Okay, so we assume that the solutions are between A and B. Some condition should be satisfied for this. Okay, for the above statement. What is that condition? That we will discuss later. So this is a bracketing method. That's why we are using a bracket, that is the solution is between A and B. Okay, that's why we are actually doing like this. Now we will see what will happen. Consider a function f of x. Okay, so first of all we will put f of x equal to 0. So let us assume that we have a nonlinear function which is going like this. Okay, this is a nonlinear function. You see, this is our f of x, and we know that where is the solution? This is the solution. This is the solution. So this is some x, and this is f of x, and this is some point xs. Okay, so the solution is nothing but your xs, such that if you put f of xs, if you put in the equation xs, for substitute the value of x as xs, you will get exactly 0. That is the solution. So if there is a solution, suppose you consider, I told you, you have to assume some initial points or initial solutions. We can say initial solutions, and it is assumed that the solution is between the points A and B. So I am just assuming some point A and B. Let's say I am assuming a point A here, and B here. Okay, now what is f of A? You see here, this point is nothing but f of A, and this point is nothing but f of B. And you can see here that this all are positive and this is negative. You can see it is clear that your f of A is positive and f of B is also positive. Am I correct? Yes, that means that your f of A is greater than 0 and f of B is also greater than 0. Both are positive. That means this is positive and this is also positive. So in between this, actually you can see this is the graph in between A and B, and there is no solution. The solution is outside this interval. So no solution in between A and B, if the condition is like this. Now I assume another point. Let's say this is my A dash. Okay, and I assume a point here which is my B dash. So what is f of A dash? F of A dash is a positive number. That means it is greater than 0. So my f of A dash is greater than 0 or positive. Okay, and you see here f of B dash is negative, which is less than 0. So f of b dash is less than 0. That means it is negative. You see here that exactly the solution is here. You see, this is the solution. So the solution exists between this a dash and b dash. That means the solution is there in the interval a dash b dash. Okay. So what I am saying is that if you have a graph like this, or if you have another graph like this, and this is the solution, your axis, and this is the solution, axis, and if you assume 2 points, let's say this is a and this is b, next you will get here f of a which is greater than 0, and this is f of b which is less than 0. Now similarly you will get some point here a, and this is your b, and this is the point f of b, and this is the point f of a which is less than 0, and this is f of b which is greater than 0. Let's say this is f of b which is greater than 0. You see here in this f of a is greater than 0, that means positive, and here f of b is less than 0, this is negative, and here f of a is greater than, not greater than, here f of a is less than 0 and f of b is greater than 0. That means this is negative and this is positive. That means you are getting two different sign here, different signs, and here also different signs. Okay, and you see now the solution is here, right? This is the solution, actually this is the solution, axis, and here also you should see the solution is between a and b. Now the solution is between a and b, and here also the solution is between a and b. So the solution exists. Here also the solution exists in the interval a and b, and here also the solution exists in the interval a and b. So this is the beauty, actually. So if you know to a and b, and if you find f of a and f of b, and if you are getting two different signs, that means one is positive answer and another is negative answer, then the solution is between a and b. So we will use this procedure to find the solution. So I will go in detail now. So let us assume that a function f of x is like, okay, this. Now what I am going to do, my procedure is, I have suppose some a, I want to find this point, this is my objective. I need to find, this is the solution, actual solution. I can say this is the actual solution. Okay, I am not going to write it here now. So this is my actual solution. I need to find it anyway. Now I assume that I have some a and b. You see, I have now f of a which is less than 0. Now this c f of b, suppose this is positive axis and this is negative axis, f of b is less than 0, this is f of x. Okay, so f of b, now the solution is between a and b. Now in bisection method, I will find new solution, because new solution is between a and b, new solution by taking the average. That means as a plus b divided by 2. So a plus b by 2 may be somewhere, let me say, okay, maybe somewhere in between. New solution is somewhere in between. Okay, this is my point, a plus b divided by 2. Let's say, okay, a plus b by 2. Now this is my point. So this point is nothing but a plus b by 2. Okay, now what is that f of a plus b by 2? F of a plus b by 2, or f of a, this is nothing but new solution xs1. I will say this is xs1. It's not the actual solution, it is the new solution xs1. So I will find f of xs1. Now you see here, this point, actually this is less than 0. Now can you tell me actually where is the solution? Whether the solution is between a and xs1 or xs1 and b. Where is the solution? Actually the solution is between this, in this interval. Actually here is the solution. So here is the solution, and there is no solution. Why? Because if you take f of a, if you take this f of a, which is negative, and this value is also negative, this value is also negative, this is negative and this is also negative, so that there is no solution. Because I told you, whenever we have negative and negative or positive, there is no solution. So this is applicable not only for positive. If we have a condition like this, okay, and this is your a and this is b, this is f of a less than 0, and here also f of b less than 0, here f of a is less than 0 and f of b less than 0, that means negative, then no solution between a and b. So this is applicable to, so there should be a sign change. One sign should be positive and another should be negative, or one can be negative and another should be positive, different signs. So you see here actually in this interval, f of a less than 0 and f of x1 less than 0. So no solution. So this is not the correct answer. But here if you see, f of xs is less than 0 and f of b is greater than 0. So negative and positive. So the solution exists between. So new interval is nothing but, so new interval is nothing is xs and b. That is, your new a is xs and new b is b itself, your old b itself, same. But new a, this is your new a is nothing but your xs. Okay, so like this. After that you will find again the average. You will do this, repeat, that means you will find a plus b by 2. You will get some xs, this is xs1, you will get the new solution xs1. Then you will check for f of xs1 and f of b. B is already there, that's why you just need to find only f of xs1. Okay, so then you will decide which one, then you will decide how to proceed. Where is the solution? Then decide. Okay, we will see a problem, then it will be easily understandable. Okay, we will see a problem. Use the bisection method. Use the bisection method to find the root of equation x cube minus 4x minus 8.95 equal to 0. Accurate to 3 decimal places. That means we should get a correct answer for 3 decimal places using bisection method. Okay, bisection method. So you have to first to find where is the solution. So assume the initial values between, assume a is equal to 2 and b equal to 3. So we will see whether the solution exists between a and b. Assume that we have now f of x is equal to x cube minus 4x minus 8.95, okay, which is equal to 0. This is our equation. We have to find the value of x. So first of all, you know that a equal to 2. Now we will find f of a. F of a is equal to q cube minus 4 into 2 minus 8.95. So this is nothing but 8 minus 8 minus 8.95. You see here this number, whether it is greater than 0 or less than 0. So this you will get as minus 8.95, which is less than 0. So now you got f of a is less than 0. Now we will see what is the value, what is the situation for b. Now we will see what is the situation for b. b equal to 3. Okay. Now f of 3 or f of b is equal to 3 cube minus 4 into 3 minus 8.95. So you will get this answer as 6.05, which is greater than 0. That means your f of b is greater than 0. So you see here one is negative and another one is positive. That is, the solution is between, so the solution is between A and B. Okay, so we can proceed now. So for that I will just draw the table. So I have some n here for the nth iteration, n for the iteration index, because I told you all these are iterative method. I have some A, I have some B. So I will find my f of A, and then B, f of B, and my new solution xs1. Okay, I have no space here. So iteration index A, f of A, B, f of B, then new solution xs1, then f of xs1, then my delta, how much is the difference between, where is the solution like interval. Okay, this is the interval width or width of the interval. So that's it. Now I am going to draw the table. Okay, now this is my iteration index 1, 2. Okay, iteration index, this is my iteration index 1, 2. So iteration index 1, 2 like this. So this is my iteration index. Now first iteration, my 2a is equal to 2. We know that a is equal to 2, and b is equal to 3, and f of a we have already got it, minus 8.95, and f of b is 6.05. Now my new solution is nothing but xs. So how we will find it? We will find xs is equal to a plus b by 2. That means you will take the average of this a and you will find the average of this 2 and 3. Average of 2 and 3 is nothing but 2.5, right? It is 2.5. So you got it, 2.5. Now we will get f of xs1. We will find f of xs1. What is f of xs1? Is nothing but you will use this equation. That means you know this is your f of x. So you will put xs1. The value of xs1 is 2.5. So you will put f of 2.5. And what is this answer that you are going to get? It is minus 3.25. It is minus 3.25. So you will get this. Okay. So now where is the solution actually? Now you can see that the solution is, you can see f of a is negative and f of xs is negative. So there is no solution between the both of them. So the solution is between you can see here that for f of b it is positive and f of xs is negative. So what is b? B is the higher value, which is 3, and xs is the lower value, which is 2.5. So my new a is nothing but 2.5, and my new b is nothing but 3. Okay, and you know that f of 2.5, we have already seen what is f of 2.5, so we can put it here because this is the new a. So f of a means f of 2.5, f of 2.5, which is equal to minus 3.25. Got it? Now this is my b, and we know that f of b is 6.05. Okay, f of b is, or f of 3, this is f of 3, which is equal to 6.05. Now we got it. So now you see here, one is negative and another is positive. Okay, and we will get the average of these two as now we will find again by using this rule, that means a plus b by 2. So we will find the average of 3 plus 2.5, 3 plus 2.5 divided by 2. Okay, so you will get this answer as 2.75. Got it? Now you can find the f of 2.75 here, which is nothing but f of x is 1. You will get it as 0.84688. Okay, 688. Now what is this thing? You see here, my new interval, actually my new interval is here. My new interval is between 2.5 and 3. So what is the width of this new interval? It is nothing but absolute value of my 3 minus 2.5. It is nothing but 0.5. This is my new intervals. That is, the meaning is that my solution is within a range of 0.5 now. That is, I can expect a maximum error of 0.5. I cannot expect an error more than that because my solution is between 3 and 2.5. So maximum error I can expect is 0.5. So what is the error I can expect here maximum? I can expect here, you see my new value of solution, you see one is positive, this is positive, and this is negative. Where is negative actually? Yeah, this is again positive, but this is negative. So my solution is between 3.25 and where is my solution? Where is my solution? My solution is between 2.5 and, so you see this is f of, so my, sorry, this 3.25 is not a, this is a function value. So this is x is 1, my x1, this is positive, and there is one negative here. You see here, this is negative and this is negative. So what is the corresponding value? I have, this is 2.5 and the another is 2.75. So my solution is between 2.5 and 2.75. So what is the maximum error I can expect? My solution is between 2.75 and 2.5. So my maximum error I can expect is 0.25. So you see here that it was previously 0.5. Now maximum error I can get is 0.25. That is half of the first step. So where is my solution now? My solution is between, now I am going to write my solution because you see here this is negative. So I will take what is the corresponding value. This is f of a. So what is the corresponding a for this? Actually the corresponding a is 2.5, and my b was again positive, so I cannot take it, but my x's new point is my b was actually positive, that is okay, but I have my point which is very close to a, which is nothing but this is also positive. So I will take this point 2.75 because 3 was in previous iteration. So I will take this point, this is my 2.75. So you see here, now my new a is 2.5 and new b is 2.75. okay, my f of 2.5 is minus 3.25. we have already seen it, and this 2.75 as the function value. 0.84688. Now I will find a plus b by 2. That means that 2.5 plus 2.75 divided by 2, which is nothing but actually 2.625. 2.625. Okay, and I will find the function value f of 2.625, which is equal to minus 1.36211. So I got it, and this I will get this value as my new value is, where is my solution now? My solution I have to find. So this is the second iteration. Sorry, I will just put the iteration number 1, 2, 3 and 4. Okay, now new solution, you see this number is positive, negative, and this number is negative. So the solution is not between these two. Okay, but you see this is positive. Okay, so the solution is between, you see the solution, sorry, not this positive, this is the number anyway, f of this is positive. So the solution is between b and x's. What is that b? You see the solution is between now b and x's. So this is the solution is between now b and x's, because f of b, you see this is b, f of b is positive, and you see here this is x's, and f of x's is negative. Okay, and so the solution is between b and new interval. So we will always compare with the new value. Okay, we will always compare with the new value. So new value is negative, and one of the old value which is positive that we will take. You see this is positive, but this is negative, so we will not take it. Why? Because this is already negative, so we will not take again negative here. So there is no solution. So we will take this value. So what is that? This is 2.75 and this is 2.625. So which is the lower limit? The lower limit is 2.625, because 2.625 is the small value. So I will write it first, 2.625, and this is the upper limit, which is 2.75. Okay, now 2.75 and 2.625. Okay, now what is f of 2.625? It is minus 1.36211. It is directly from here anyway, and this f of 2.75 is nothing but 0.84688. Okay, now we will find the new solution as 2.625 plus 2.75 divided by 2. So what is our new solution? 2.6875. Okay, 2.6875. Now you will get this value as f of that value as negative. That means 0.2 minus 0.28911. Okay, and the width of the interval in the previous iteration itself, you will get this is as 0.125, and here you will get it as 0.0625. anyway, that will become half. Okay, like half. This divided by 2, this divided by 2, like this it is going on in bisection method. So you got it. Now you see here this answer is negative and this answer is also negative. So there is no solution between 2.625 and 2.6875. Now this answer is positive, so the solution is between this value and this value. Okay, that means the lower limit is 2.6875 and the upper limit is 2.75. Okay, so again we will take the 2.75. Now what is the f of 2.75? is 0.84688, and what is the value of the function here 2.6875, it is nothing but minus 0.28911. Now we will find the average again. Okay, if you take the average, you will get 2.71875. okay, you will get this, and if you take the f of that x1, you will get it as 0.27092. you see here that the value of f of x is now decreasing. Initial iteration it was minus 3.2, and now it's decreasing, and now it's become 0.2. whenever it become close to 0, you can stop anyway. So but in the question it is given that we need 3 decimal places accuracy. Okay, now this become 0.625. okay, this become, you just take the difference between these numbers. Okay, now anyway, I will first write this iteration index. Okay, now we will see this is nothing but the absolute value of, you see here this answer is negative, this answer is positive, this is also positive. So where is the solution now? Now the solution is between, I need a negative and positive. Okay, so I know that this is positive and this is positive. So the solution is between 2.6875 and this number, that means this one, 2.71875, because this function value is positive and this function value is negative. Okay, so that's why. So we will always compare our new value, our new function value with the previous two. If it is having the same sign, we can avoid. So what we are actually going to do, we are finding the middle point basically. So what we are going to do is that we will find, we have A and we have B, and you will find your x's here. Then you see this is less than 0 and this is also less than 0, both are negative, so no solution here. So I will choose my interval between, this is my new A and this is my new B, and again I will find the new solution, x is here. Then I will take this interval and this interval, this is positive, so no solution here. So but this is positive and this is negative, so the solution is between here. So my new A is here and new B is corresponding to this. Then again I will find A plus B by 2. So this is what the procedure which is going on. Now this is, now f of 2685, this is nothing but 0.28911, and this is nothing but 0.27092. okay, f of x. Okay, now what is happening here? What about this value 0.00625? we know the error pattern. This is 2 by 2, this becomes 0.0625 by 4. Then next error you can expect like this, 0.0625 by 8. That means it is dividing by 2, 2, 2 like this. Okay, now what is the new point? What is the new point? If we use 2.6875 and 2.7185, the new point will be 2.70313. that is the new point. Okay, and if we take the f of that point, function value of that point, it is nothing but minus 0.01108, and the error will be, of course, it will be like following this pattern. So this is 6. Okay, now you see what is the situation. Now you see here this is negative. Okay, and we will see the function value which is positive, and this is negative. So definitely the solution, if I compare this guy with this one, with B, the solution is between B and the new point. But if I compare with the A, the old A, actually the solution is not lying there. So I have one point, it is 2.2, that is the B, 2.7185, and this is nothing but 2.70. So this is the lower point. I will first write this one. This is the smaller value, 2.70313, and you can write any value as over lower and higher value. There is no issue. You will get the correct solution. And this b is nothing but 2.71875. Okay, and this function value is 0 point, it is nothing but minus 0.01108, and this is nothing but 2.7092. so this is the seventh iteration. So in the seventh iteration you are getting as this is 2.70 and 71. Okay, so we will get to the new point as 2.71094. okay, that is the new point. And if you take the function value at that point, you will get it as 0.12942. okay, 0.12942. now you see this is positive. Okay, and this function value is positive, but this function value is negative. So you will compare this guy with the previous positive and negative, but here this is positive, so no solution between this interval. So this is correct. So we will choose this. That means the old A. So what is the old A? Is 2.70313. So I will continue this. Okay, so this is the way you can continue. So you can see that slowly the iteration is continuing, converging. That means the answer is now 2.71 here, and this answer is 2.70 here, again 2.71 here. So your answer is approximately, now I am stopping this iteration because you can continue in the same way, but in the question I have given you for 3 decimal place, but I will correct it for 1 decimal place, because even for 3 decimal place it will take more iteration. So the convergence speed is actually less, so it's 1 decimal place. Okay, so if it is 1 decimal place, you see here I am getting almost as 2.71 here again. So my answer is 2.71, okay, or 2.7. you can see I am getting 2.7 throughout. I am getting here 2.7 here, 2.7 here, 2.7 here. Okay, 1 decimal place is okay. So for 1 decimal place my answer is 2.7. if it is for 3 decimal place, so my solution, if it is for 3 decimal place, you have to continue with more number of iteration. So I hope the procedure is clear to you. Okay, so solution is 2.7. okay, that is the solution, which is correct for 1 decimal place. Okay, thank you.